Today we will study atoms and molecules, 9th standard CBSE and state syllabus chemistry chapter. When we see about the atom, it is not only the today's our modern information, but even during the ancient time, the people had little idea about this atom. Let me see about this. Like when we talk about the ancient Indian, around the philosophers' ideas, around the 500 BC, an Indian philosopher, Maharishi Karnad, he postulated that if we go on dividing matter, that is Padartha, we shall get the smaller and smaller particles. Ultimately, a stage will come when we shall come across the smallest particles beyond which further division will not be possible. He named these particles Parmanu. Another Indian philosopher, Pakadu Katyayana, he said that these particles normally exist in the combined form, which gives us various forms of matter. Around the same time, ancient Greek philosophers Democritus and Leucippus suggested that if we go on dividing matter, a stage will come when particles obtained cannot be divided further. Democritus called these indivisible particles atoms, meaning indivisible. But all these ideas was based on philosophical consideration and not much experimental work to validate these ideas could be done till the 18th century. By the end of the 18th century, scientists recognized the difference between elements and compounds and naturally become interested in finding out how and why elements combine and what happens when they combine. Anton L. Lavoisier, he laid the foundation of chemical sciences by establishing the two important laws which was known as the laws of chemical combination. To prove these laws, he had done the activity. He had taken the combination of the two chemicals. He had taken the combination of the two chemicals and he had weighed the weight or the mass of this chemical before and after the reaction, chemical reaction takes place. Let me understand it. Yes, like here you can see the example. He had taken the one chemical, that is a sodium chloride solution, into conical flask. Another substance, that is a silver nitrate solution, he had taken into the small tube called the ignition tube. He didn't mix this both the chemicals, but this ignition tube carefully he tied with a thread and he closed the conical flask by using the rubber cork. The care has to be taken that these two solutions will not mix. He noted the mass of this setup. After noting the mass of this, he shake this conical flask and allow the silver nitrate solution mix with the sodium chloride solution, so that the reaction takes place between these two solutions. He measured and noted the mass of this again after the reaction takes place between them. One precaution is taken, this rubber cork should be airtight. And he noted that there is no change in the mass before and after the reaction. He repeated this with a lot of combination of the chemicals, and he got the same result. Now question come here, why he put a cork on the mouth of the flask? Sometime during the chemical reaction, there is some gases released like hydrogen gas and all that, and that should not be escaped. If it escape into then the mass will varies after the reaction. So based on this activity, he had proposed the law of conservation of mass, which states that mass can neither be created nor destroyed in a chemical reaction. Yes, you can see the first law here too, that is the law of conservation of mass, which states that mass can neither be created nor destroyed in a chemical reaction. Again later on, he had observed many compounds, and he observed these compounds are made up of 2 or more elements, and each such compounds had the same elements in the same proportions, irrespective of where the compounds came from or who prepared it. For example, if we say about the water, whichever source the water is obtained, whether the water is from the river, lake, pond or ocean, sea, or the groundwater or rainwater, whichever the water he had collected, he observed that the ratio of mass of hydrogen to the mass of oxygen is always 1:8. Same way he had observed in the ammonia, the mass of nitrogen and hydrogen is always present in the ratio of 14:3. Whatever the method or the source from which this ammonia is obtained. And this led to the second law of constant proportion, which is also known as law of definite proportion. According to this law, in a chemical substance, the elements are always present in definite proportion by mass. Now the next problem faced by the scientist was to give an appropriate explanation of these laws. British chemist John Dalton provided the basic theory about the nature of the matter. He picked up the idea of indivisibility of matter, which was till then just a philosophy. He took the name atoms as given by the Greeks and said that the smallest particle of matters are atoms, and we cannot divide the atom further. And he proposed the atomic theory, which is known as the Dalton's atomic theory. According to the Dalton's atomic theory, all matter is made up of very tiny particles called atoms, which participate in chemical reaction. Atoms are indivisible particles, which cannot be created or destroyed in a chemical reaction. Atoms of a given elements are identical in mass and chemical properties. Atoms of different elements have different masses and chemical properties. Atoms combine in the ratio of small whole numbers to form compounds. The relative number and kind of atoms are constant in a given compound. Later on, now when we say so much about the atom, what is the atom? When we say the atoms are the building blocks, which are the smallest particle of the matter, as I told in the beginning of the lesson. Now Dalton tried to give the symbols for elements as proposed. Now these elements symbols are useful while writing the chemical equation and the chemical symbols. Now some of the symbols what he have proposed I am just showing here. Like when we say hydrogen, the symbol is a circle and in that one small dot. Carbon is again the circle, but inside it is blackened. Oxygen again circle, but inside it is whitened. Oh my God, so much confusing it is. Really, I'm getting confused with these symbols. Right? And it was the same with the others also. Now today's the modern symbols were suggested by Burgillus. Whatever the modern symbols we have using. Now what is this modern symbol? Now you can see these are the modern symbols what we are using, which are all over the world it is accepted. Now for example, the symbol of aluminium is Al, barium is Ba, hydrogen is H, potassium is K, cobalt is Cu. Like this there are so many symbols and just the samples I am showing. Till date we know 118 elements. I am just showing the few element symbols I am showing. But again I am getting the confused here. Why for the some elements the symbol is only one letter, like for carbon C, oxygen O, hydrogen H. And why for some elements it is the two letters are there. Let me understand while giving the nomenclature. Nomenclature, that is the naming, and the symbols giving. Yes. The first thing is, for the few letters, the first letter is used as a symbol of that element. For example, hydrogen H, oxygen O, carbon C, boron B, nitrogen N, so that. We can see the second example. Here, two letters. First two letters of the elements are used as a symbol. And whenever there is a one letter used as a symbol, it is always capital. And when there is a two letters are used as a symbol of the element, first letter is capital and second letter is always small letter. That you have to remember. Now, as I told, for the few elements, first two letters of their name is the symbol of that element. For example, when we are seeing here, helium He, cobalt Co, bromine Br, neon Ne, so that. Third case we can see, for the some elements, first and third letter of their name is used as their symbol. For example, magnesium, instead of Ma, it is the symbol is Mg. Chlorine, that is a Cl, chromium Cr, manganese Mn, so on. Then for the some elements, first letter and some other letter in their name. It is not necessarily second or third letter, but some other letter. For example, you are seeing here palladium. It is a Pd is the symbol. Platinum Pt. Yeah. And again there are some of the elements which was known in the ancient time, and their symbols are taken from their old name, that is a Latin names. For example, sodium, in Latin it was known as a natrium, and its symbol is taken as a Na from the Latin name. Potassium was known as a kalium and its symbol is K. Iron, ferrum, Fe, copper, cuprum, Cu, tin, stannum, Sn, silver, argentum, Ag, gold, aurum, Au, mercury, hydrogynum, Hg, tungsten, wolfram, W, lead, plumbum, Pb, like this. Now, it is always better you learn the name of the elements and the symbols, at least for the few which is given in the textbook, so that it will be easy for you to do the next part of this lesson, that is calculation of the molecular mass and all thing, or writing the chemical formula of this thing. And the next concept here coming, yes, the atomic mass. So when we are talking about the atomic mass, the most remarkable concept that Dalton's atomic theory proposed was that of the atomic mass. According to him, each element had a characteristic atomic mass. Let us take the example of the compound, that is a carbon monoxide. Now, as the name indicates, carbon monoxide made up of the one carbon atom and one atom of oxygen. Now, it was observed experimentally that 3 gram of carbon combines with the 4 gram of oxygen to form carbon monoxide. In other words, 1 carbon combines with the 3 times its mass of oxygen. Now suppose we define the atomic mass unit, which is earlier abbreviated as the AMU. But according to the latest IUPAC recommendation, it is now written as a U, unified mass, U for unified mass, as equal to the mass of one carbon. So when we are talking about here, so what was defined? The atomic mass unit, that is a U, unified mass. One unified mass was defined as a mass of one carbon atom. And when we define this as a one carbon atom mass, as a 1 U, then we will assign the carbon an atomic mass of 1 U, and when we calculate this, then we will get the oxygen atomic mass as 1.33 U. However, it is more convenient to have these numbers whole number or as near to the whole number as possible. Now, while searching for various atomic mass units, scientists initially took 1/16th of the mass of an atom of naturally occurring oxygen as the unit. This was considered relevant due to the two reasons. Oxygen reacted with a large number of elements and formed the compounds. And the second, this atomic mass unit gave masses of most of the elements as a whole number. However, in the 1961, for a universally accepted atomic mass unit, carbon-12 isotope was chosen as the standard reference for measuring the atomic masses. One atomic mass unit is a mass unit equal to exactly 1/12 the mass of one atom of carbon-12. The relative atomic masses of all elements have been found with respect to an atom of carbon-12. You can see here the atomic masses of few elements is mentioned here, like hydrogen 1, nitrogen 14, sodium 23, calcium 14, etc. Now the next question comes. How does this atom exist? As we have not seen the atoms. Now whatever the even today's latest technology we are not able to see the atoms. Right? Because the atoms are so small, we cannot imagine also that small. If you put one small dot with a pen or pencil, in that small dot, millions of atoms exist. That small is the atom. Now, here when we are talking, then the question comes how these atoms exist here. The atoms of most elements are not able to exist independently. Atoms form molecules and ions. These molecules or ions aggregate in large number to form the matter that we can see, feel or touch. Now, what is a molecule? A molecule is in general a group of two or more atoms that are chemically bonded together, that is tightly held together by attractive forces. A molecule can be defined as the smallest particle of an element or a compound that is capable of an independent existence and shows all the properties of that substance. Now, atoms of some elements, example oxygen, or of different elements like water, can join together to form the molecules. Now, depending upon the type of the atoms present in the molecule, there are two types of the molecule. First type, it is a molecule of elements. When you can say the molecules of an element, these are constituted by the same type of the atoms. And the number of atoms constituting a molecule is known as its atomicity. For example, when we say here, you can see in the table, like argon is made up of, the molecule of argon is made up of only one atom. And therefore, the atomicity of argon is monoatomic. Oxygen molecule is made up of two atoms of the oxygen. And that's why the atomicity of oxygen is diatomic. Phosphorus is made up of 4 atoms of phosphorus, and therefore molecule of phosphorus is tetraatomic. Molecule of sulfur is made up of 8 atoms of sulfur. The next is molecule of compound. Atoms of different elements join together in definite proportion to form a molecules of compound. So when we say about the compound, here atoms of different elements, they are joining in definite proportion. So two things you have to remember, different elements, atoms are joining. But is they joining randomly? No, in a definite proportion only. For example, when we talk about the water, in water, 2 hydrogen atoms combine with the 1 oxygen atom. The ratio of hydrogen to oxygen atom is always 2:1. When we are talking about the methane, it is a 1 carbon react with the 4 hydrogen atom. The ratio of the carbon to hydrogen is always 1:4. Like that. Yeah, now you can see the pic here. Now the top one, left side, you can see molecule of element. These are made up of the same kind of the atom. And the down and right side, you can see molecules of the compounds. Right? And you are seeing these are made up of 2 or more than 2 types of the atoms. Now, what is the ions? The ions, that is what is happening here. The compounds composed of metals and non-metal contain the charged particle. Now the charged species are known as an ion. Ions may consist of a single charge atom or a group of atoms have the net charge on them. Right? So single atom might have the charge. Or there might be the group of atoms will be having which have the net charge on them. Now, this charge may be the negative or positive charge. Negatively charged ion is called an anion and the positively charged ion is called cation. You can see here now some of the examples. Positive ions, that is cation, and name and the formula given. Like hydrogen, if you are seeing H they are written, that is the symbol of hydrogen, and top that is a plus sign. What is the meaning of this plus or negative? Now chloride you are seeing minus sign after chlorine symbol. So what is this plus or minus sign? So this is a plus sign means positive charge. Minus sign is a negative charge. And then if you are observing here, like for example barium Ba 2+, iron Fe 3+, aluminium Al 3+. What is the meaning of this? It is means if it is a 2+ given, it have the 2 positive charge. If it is written 3+, it is the 3 positive charge. Or if it is, you can see oxide 2- means it have the 2 negative charge. Again you are observing here the group of the atoms which have the net charge. For example, ammonia NH4+. Right? And right side you can see hydroxide OH-. That is a hydroxide. 1 hydrogen and 1 oxygen combined. It have the 1- charge. Carbonate you are seeing CO3. 1 carbon, 3 oxygen combined. It have the -2 charge. This group of atoms which have the net charge, this is also known as the radicals. Now, chemical formula. What is the chemical formula? Chemical formula is the chemical formula of a compound is a symbolic representation of its composition. So using the symbols representing when we are doing about any compound, it is called a chemical formula. Now how to write the chemical formula? The question comes, how to write the chemical formula. To write the chemical formula, we need some knowledge, that is we should know the symbol of the atoms of which that compound is formed, and that atoms, the valency. Valency is the combining capacity of the atom is known as the valency. In next video, I'll explain you about the valency in the detail. Now when we're talking how to write this chemical formula of the compound. So generally we use the crisscross rule. According to this rule, some of the steps we have to follow. Like always, we have to write the symbol in order. When we say the symbol in order, generally the metal symbol is written the first, that is the left side, and non-metal symbol is written the right side, that is the second. While writing the chemical formula also, first the name will start with the metal name and then it is a non-metal name. Like for example, calcium chloride. Calcium is a metal and chlorine is the non-metal. Okay, now come back with the rules. First, as I told, write the symbols in order. Second, write the valencies or charges above symbols. Crisscross the valencies, making them subscript. Divide the subscript by highest common factor. And if the subscript is 1, remove it. No need to write. Yeah. Now instead of just orally, you can see now. Now here I have to write the formula for carbon dioxide. So what I am doing now here, write the symbol of carbon and symbol of oxygen. Then you write down the valencies. Carbon valency is 4, oxygen valency is 2. You have to do the crisscross. Carbon into 2, oxygen into 4. So you have to crisscross, multiply, cross over the valencies, and when you do it, now carbon into 2, C2, and oxygen into 4, that is a O4. But we are seeing now 2 and 4 have the 2 common factor. So when you divide this with the 2, you are getting CO2. The formula is CO2. So what are the steps I told? We are followed here. First write the symbol, then write the valencies, crisscross the symbol and the valencies, and if it is having some common factors, okay, that number you have to divide with the common factor. You get the lowest term of the subscript, okay, and that is how you will write the formula. Now for carbon it was a 1, so we have to remove that 1, no need. If just C written, that is a symbol written, it means that it is a 1 in number. Yeah, here are some more examples for writing the chemical formula. Okay, like the sodium oxide, write the symbol of sodium and oxygen. Sodium have the valency 1, oxygen 2. Crisscross, and now sodium twice, you have to write Na2 and oxygen 1. Now sometime what will happen, the group of atom, that is the radicals, if they are in the any chemical compound, like for example this fourth example you are seeing, magnesium hydroxide. So you are seeing magnesium is a metal, hydroxide is a group of atom with a charge, net charge. Magnesium valency is 2 hydroxide valency is 1. When you do the crisscross, magnesium into 1 and OH, that is hydroxide into 2. So you have to write magnesium, but as the charge is a net charge on the OH, so OH we are writing in the bracket, that is hydroxide symbol, and the 2 we have to write outside the bracket. That you have to remember. So when you write the bracket, when there is a group of charged particles are there, which have the net charge on that. So their number always you are writing outside the bracket. Next is the molecular mass. The molecular mass of a substance is the sum of the atomic masses of all the atoms in the molecule of the substance. Okay, and therefore it is a relative mass of the molecule expressed in atomic mass unit. In short, you have to remember what is the molecule made up of? Atoms. So what will be the molecule mass of the molecule? It is the mass of the atoms of which that molecule is made up of. For example, you are seeing here molecular mass of methane, that is CH4. So what you will write new here? Atomic mass of carbon, because in the methane only one carbon is there. So atomic mass of carbon you have to write. Plus 4 into atomic mass of hydrogen. Why 4? Because in the methane 4 atoms of hydrogen is there. So 4 into atomic mass of hydrogen you have to write. So now atomic mass of carbon is 12 and atomic mass of hydrogen is 1. So 1 into 4 is 4. 12 plus 4 is 16. So molecular mass of methane is 16U. Same way, the molecular mass of C2H6. So here 2 carbon and 6 hydrogen. So 2 into atomic mass of carbon plus 6 into atomic mass of hydrogen. So 2 12s are 24 plus 6 1s are 6. 24 plus 6, 30U. Next is the formula unit mass. The formula unit mass of a substance is the sum of the atomic masses of all atoms in a formula unit of a compound. Oh my god, what is this you are thinking, right? So just understand, children, formula unit mass is calculated in the same manner as the we calculate the molecular mass. Now formula unit mass when we are using, okay, so we are using this word when the substance whose constituent particles are ions. Okay, now the compound whose constituent particles are ions, that time we use the word formula unit mass. For example, here formula unit mass of zinc oxide. So zinc is 1 in number, oxygen also 1 number. So 1 into atomic mass of zinc plus 1 into atomic mass of oxygen. Atomic mass of zinc is 65 and atomic mass of oxygen is 16. So 65 plus 16, you got the 81U. Right? The same way you have to calculate the formula unit mass. Hope so you like this lesson. You understand? Don't forget to like, subscribe and share my channel. Thank you. Bye bye.